Welcome to the DIY Honda Garage channel. Welcome to this detailed troubleshooting guide on Diagnostic Trouble Code P0533, which refers to a high voltage condition detected in the AC pressure sensor circuit. This condition can negatively affect the performance of the air conditioning system in the Honda Fit model years 2015 through 2020. Understanding and resolving this issue is crucial for maintaining optimal cabin comfort and system efficiency. The AC pressure sensor measures refrigerant pressure and provides feedback to the powertrain control module, PCM, for system control. A fault in this sensor can trigger DTC P0533, which alerts technicians to potential malfunctions. This presentation will guide you through troubleshooting steps, possible causes, symptoms, and preventive maintenance strategies, resulting in a comprehensive approach to resolving this DTC. DTC P0533 arises from issues with the AC pressure sensor circuit, particularly indicating high voltage levels. The AC pressure sensor is responsible for measuring the pressure of the refrigerant in the air conditioning system. It relays this information to the powertrain control module, PCM, which adjusts the operation of the AC system accordingly. Typically, this sensor is located in the engine compartment, often near the condenser, connected via a wiring harness. The role of the sensor is essential for efficiency. Incorrect readings can lead to improper system functioning, affecting comfort levels within the vehicle. When high voltage is detected, the PCM interprets this as a fault condition, triggering DTC P0533. Several underlying issues can trigger DTC P0533, starting with a faulty AC pressure sensor itself. If the sensor is malfunctioning, it may relay incorrect voltage levels to the PCM, prompting the error. Poor electrical connections, including corroded or loosely fitted terminals, can also cause inconsistent signals, leading the PCM to detect high voltage. Damaged wiring, such as fraying or breaks in the circuit, can further complicate communication between the sensor and PCM. Any of these causes can create incorrect pressure readings, prompting the PCM to trigger the DTC, indicating a comprehensive need for checks and assessments to ensure optimal performance. Drivers may observe several symptoms when DTC P0533 is present. The AC system may completely fail to function, leaving occupants without cooling in high temperatures. Alternatively, the performance of the AC may become erratic, with unpredictable behavior, such as intermittent cooling. This can lead to frustration, especially during hot weather. Increased cabin temperature is another significant symptom, which indicates that the refrigerant pressure is not being properly regulated due to the circuit fault. These symptoms highlight the importance of addressing DTC P0533 promptly, as they directly impact driver comfort and overall vehicle usability. The first step in troubleshooting DTC P0533 involves verifying the problem by assessing the AC system's current conditions. Start the vehicle and allow it to idle, which provides a stable environment for diagnostics. Next, turn on the blower switch and activate the AC switch to engage the system. Utilizing the Honda Diagnostic System, HDS, check the parameters related to the AC pressure sensor. Specifically, confirm that the sensor voltage value exceeds 4.75 volts. If the readings match this threshold, you have duplicated the failure and can proceed to the next step. Conversely, if the readings do not match, it indicates a potential intermittent issue, necessitating checks for loose connections or faulty terminals. Proceeding to step 2 requires first turning the vehicle off and ensuring safety protocols are followed, particularly focusing on disconnection procedures. Disconnect the AC pressure sensor 3P connector, which allows you to isolate the sensor from the circuit. Next, use a jumper wire to connect terminals A and B on the connector, effectively bypassing the sensor. Following this, turn the vehicle to the on mode and check the parameter readings once again with the HDS. The objective is to see voltage levels exceeding 4.75 volts. If they do, continue to the next step. If not, it is advisable to replace the AC pressure sensor, which may not be delivering accurate readings. In the third troubleshooting step, take the vehicle back to the off mode, ensuring proper precautions are adhered to while working with the electrical systems. Remove the jumper wire from the AC pressure sensor 3P connector, returning the circuit to its standard configuration. Next, turn the vehicle to the on mode again to facilitate diagnostic checks. Measurement of the voltage between test points 1 and 2 is crucial at this stage, specifically using the AC pressure sensor 3P connector, which should be disconnected. Here, you are looking for approximately 5.0 volts. This will confirm that the sensor circuit is functioning correctly. If you find the voltage is within expectations, you can advance to the next step. Otherwise, deeper inspection into connections or wiring issues may be necessary. For the fourth troubleshooting step, turn your vehicle off again to carry out necessary connection tests. Jump the SCS line with the Honda Diagnostic System, HDS, a process that allows for precise diagnostic testing without interference from the system's normal operations. Following that, disconnect the PCM connector AP to prevent power interruptions during testing. Check for continuity between test points 1 and 2, specifically between the AC pressure sensor 3P connector, number 2, and the PCM connector A, number 41. Continuity indicates that the PD sensor wire is functioning properly. If continuity is confirmed, consider updating the PCM software or replacing it if found outdated. If DTC P0533 disappears after these actions, troubleshooting can be considered complete. The final troubleshooting step mirrors the prior one, but focuses on a different wiring line, specifically the SG5 line. Again, start by turning the vehicle to the off mode for safety. Jump the SCS line with the HDS as a precautionary measure prior to checks. From there, disconnect the PCM connector A, 51P, to isolate the systems correctly. You will check for continuity between two specified test points, the AC pressure sensor 3P connector number 1 and the PCM connector A number 39. Finding continuity here confirms that the SG5 wire is intact. Should continuity be confirmed, consider updating or substituting the PCM once more based on previous outcomes with DTC P0533. On the other hand, failure to find continuity necessitates repairs on the SG5 wire, which indicates a potential break or failure in the circuit. After completing the troubleshooting steps and necessary repairs for DTC P0533, it is crucial to undergo final verification to ensure all issues have been resolved. Begin by rechecking the system operation thoroughly. Clear any diagnostic trouble codes, DTCs, from the PCM, and retest the AC system under varied operating conditions to confirm the absence of any further issues. This should involve checking not only the AC performance, but also ensuring that no new DTCs appear during this process. Confirming the functionality of the AC system is vital, ensuring all components work as they should, which includes routine checks on cabin comfort. If everything checks out, you can confidently ensure that the repair has restored the system to full functionality. Preventive maintenance plays a vital role in prolonging the lifespan and reliability of the AC system, particularly to avert issues like DTC P0533 from occurring in the future. Regular system inspections can catch anomalies before they escalate into major failures, which can save time and money. During these inspections, it is pertinent to check all wiring and connections, ensuring that integrity is maintained across the circuits. Additionally, maintaining proper refrigerant levels within the AC system is crucial, as low refrigerant can skew pressure readings and impact sensor performance. By being proactive about these aspects, you can minimize the likelihood of DTCs and enhance the comfort of your Honda Fit. In conclusion, DTC P0533 signifies a high voltage issue in the AC pressure sensor circuit, which can severely affect the temperature regulation within your Honda Fit. Following systematic troubleshooting steps is essential to identify the root cause of this error effectively. Each step should be conducted meticulously to ensure accurate diagnosis. Additionally, integrating preventive maintenance into your routine can significantly reduce the chances of similar DTCs occurring in the future. Awareness and understanding of the AC system's components and their functions are vital to preserving your vehicle's performance. By adhering to these principles, not only will you resolve existing issues, but you will also enhance the longevity and efficiency of your AC system. Please like and subscribe to the channel. See you next time.